And welcome. Um, Here is one problem related to equilibrium, forces, and torques. And the problem is about we have two small balls, of same mass and carrying same charge Q, and are suspended via two strings of same length L on the ceiling at the same point. This is the point of suspension, nothing else. And well, as a result of which the strings branch out as shown in the figure. Determine the mass m of the balls. That means mass is not given. Okay, it is only written for reference. So we will try to find out the masses of the balls. And in another experiment, the right hand ball is replaced by the ball of same charge but 3 times the mass. Its charge is retained but mass can be changed to 3 times. How much charge on the left ball should be placed on the same mass? That means its mass. Okay, so that the distance between the balls is in equilibrium. That means its charge and its mass both is changed in the second experiment, so that the distance between the balls in equilibrium state remains L. That's right. And right now, I guess everything is written here, and everything I can see on the screen. That's right. Okay, fine. So same mass, same charge, and the forces acting on. And one thing I would like to notice here, that the center of gravity masses of strings are negligible, I guess. Of course, they are, until and unless it is provided as an information. So center of gravity of the two masses, because they are the only one who are carrying some mass, equal mass, so their center of gravity lies at a point at the midpoint of the line joining them, and that should be right beneath the point of suspension, right below the point of suspension. So the equilibrium is looking fine to me, and I'm going to consider, and this angle is also 30 degree because the picture is an equilateral triangle. So I'm going to draw the free body diagram of any of these masses because both will have same. So this is the electrostatic force. Its direction will be different on this, and the force of gravity acting on it like this, and there will be the tension in the string. And since Fe and Mg are same on both of them, that means tension is going to be the same in both of the strings, and tension will be in this direction for the balls to remain in equilibrium in a direction. The resultant of Fe and Mg in a direction opposite to the direction of resultant of electrostatic force and force of gravity. And so this angle is going to be 30 degree. That means I can write something like tan 30 degree is equal to Fe, the perpendicular, divided by the base mg, the force of gravity. And since tan 30 degree is 1 upon root 3, and Fe will be equal to kq square. K is the electric constant here. 1 upon 4 pi epsilon naught, kq square by L square. And mg. That means I can get the value of m from here. And so anybody can calculate the value of m from here, and my job ends to find the value of m. I am worrying about another experiment, which is a different one. In this experiment, this mass has been changed to 3m, and the charge on it needs to be replaced so that the distance between them should be L. But one thing is worrying me, that center of gravity now will shift towards 3m. Center of mass will lie closer to the 3m, and this should be right beneath the point of suspension on this line. That means this picture is going to change in the new case. It will become something like and yeah, and yeah. So I guess picture will be changed like this. 3m will be here, so that the force of gravity acting on it will be 3mg, and electrostatic force will be acting like this on this, and this is the electrostatic force acting on the ball of mass m. So the force of gravity is mg here. Still, this angle is 60 degree, but these two angles are unknown. I guess they are alpha and beta, and the system is in equilibrium. Whole system is in equilibrium. So what can we do to further proceed now? I think we will be needing to find out the angles alpha and beta. And the geometry of the figure doesn't provide any clue, because there are two unknowns, and we can only say that here alpha plus beta plus 60 degree is equal to 180 degree and nothing else. And they are all in equilibrium, and system is also in equilibrium. So net forces acting on each of them is also equal to 0. But this is the main problem. Before we are going to use the net forces, we will be needing to find out alpha or beta, at least alpha or beta, any one of them. And we don't have any clue. And but Since the whole system and the individual objects are in equilibrium, so the net torque on the whole system about any point in this world is equal to 0. And same goes about the individual objects. So, and the tension forces has also changed. This is an extra problem. So I'm going to choose this point of suspension, at least to avoid the torques produced by T1 and T2, the tension forces. And I guess if we take the whole system, we can avoid the torques of these electrostatic forces as well, because the net electrostatic force acting on the system is equal to 0. They are internal forces for the system. They are equal and opposite. They are acting on different bodies, and that's all. They are internal forces of the system, and their values must be equal to 0. So the torque producing forces are only forces of gravity. One is 3 mg, or moment arm is this, and its moment arm is this. Oh yeah. So I would like to call its moment arm of mg as x, and moment arm of 3 mg as x, and moment arm of mg as y. And 3 mg is producing a clockwise torque, and mg is producing a counterclockwise torque. So their torque balance equation will be something like 3 mgx, or 3 mgx or mgy equals 3 mgx. That's true. And x here is the length, or L. So x is equal to L cos beta, and y is equal to L cos alpha. That means we have a relation like L cos alpha, that is equal to 3 L cos beta. That means cos alpha is equal to 3 cos beta. We have a relation, and we have a relation too, that is alpha plus beta equals 120 degree. Alpha equals 120 degree minus beta, and we can put it right here, and we can get some result. In place of alpha, I would like to write it 180 minus beta, I will write, and cos beta. We get a relation for beta as a single unknown. So we are going to find the angle beta, and once we get beta, we can easily find alpha, or who knows, we don't be needing to find the value of alpha. So first calculate, and I'm going to expand this relation. This will be cos 180 degree cos beta plus sine 120 degree sine beta, and that is equal to 3 cos beta. So next is minus of cos 120 degree cos beta plus root 3 by 2 is sine 120 degree cos 30, yes, sine beta equal to 3 cos beta. Just if we can divide both sides by cos beta, we can get the value of tan beta, and tan beta is 7 upon root 3. I got something I needed. So now what? We can go for forces, or we can simply apply the same thing. Net torque is also equal to 0 for any individual object, and if we can take this object to apply the net force, net torque acting on it is equal to 0. The torques of all the forces acting on it is equal to 0. We will be needing and about the same point of suspension, because it is an equilibrium, so torque of forces acting on it about any point it's in this universe is equal to 0, and they are also at rest. So to do so, we'll be needing the line of action, the moment arm of Fe. This thing is the line of action of force Fe. So this is going to be its moment of arm, and it's producing a counterclockwise torque, and 3mg is producing a clockwise torque. And I know for sure that this angle is equal to 30 degree, because it is still an equilateral triangle, nothing has changed, and its moment arm is being L cos 30 degree. So I'm ready to write the moment equation for mass 3mg now, and this will be simply as 3mgx, that is equal to electrostatic force multiplied by L cos 30 degree, its moment arm. And this 3mgx is perhaps L cos beta. Yeah, x is L cos beta. So I'm going to write down here L cos beta equals Fe is still kq square by L square multiplied by L. Cos 30 degree is root 3 by 2. And putting all those things, we can, and also putting the value of m we earlier got, you can get the value of q dash. This is not kq square, this is this time kq dash, and we needed to find out the value of this q dash. And you can put here m, L is given, so you don't need to worry about L. But if you put all these values, I hope you will get q dash equal to 3 root 3 by under root 13q. You will need to put the value of beta, cos beta as well. You have tan beta, you can derive your cos beta. I'm not going to do these things because these are simple things anyone can do. I just provided a method to solve it, and thank you very much for watching.